I wanted to give you guys some help over some of the questions that I knew that we would struggle with over the homework. So, one thing that is just kind of a little side note with a very easy equation, sometimes you guys tend to overthink these problems. If I'm going to solve this equation, I'm going to divide by 9, right? And this is where a lot of students kind of start looking and they're going, well, I don't, 3 divided by 9, they may accidentally think it's a 3 as the answer, but 9 does not go into 3 times, okay? 9 times 3 isn't 3, that's what this is asking, is 3 divided by 9. So instead of thinking of it as a division problem, this is also a fraction setup, right? So 3/9 simplifies to 1/3. That's the easiest way. You could come out to the side and actually do the division of how many times 9 goes into 3, and 9 goes into 33 times, and you get 27, and you're going to realize pretty quick that you're just going to get 0.3 repeating over and over and over again. So when that happens, that's the same as 1/3. This is just the easy, simplify the fraction, okay? Speaking of fractions, I know y'all are going to want me to work this one because you see fractions, you don't even think about what's happening in this problem. You just automatically get a little bit scared. So, you would normally, if I'm trying to isolate y, right, there's nothing to simplify. There's no multiple variables that I have to combine. I can go straight to solving. My first step on this is going to be to cancel out -1/8. We're going to add 1/8, okay? If you will just try to do the math for a second, 7/8 plus 1/8 is 1/2, right? And then I still have the 1/2 y. Now, from this point, you have a couple of different approaches you can take. You can always go decimal and view this as 0.5 y equals 1 and do the math that way. Or when you're multiplying by a fraction, the way you cancel out is to multiply by the reciprocal of that fraction. So you can do it that way because those will cancel out. 2 times 2 and 1 times, or sorry, 2 times 1 and 1 times 2 just kind of makes 2 over 2, which is 1. They essentially cancel each other out like that. And you end up with 2. If you divide by 0.5 over here, you're saying how many halves fit into 1/2. It makes sense that it's leading back to this 2, okay? So that is probably the easiest 2 ways. There is another way to do it, but I'm afraid that's going to cause some confusion. So if you know the third way, then awesome, but otherwise, that clarifies that. It's not as hard a problem once you actually look at the numbers. The word problems tend to be still a weakness, so I'm going to work through one of those to kind of help you out a little bit. 5 times the sum of a number and 3. So I'm going to go ahead and just start writing this. 5 times the sum of a number and 3 is the same as. Okay, is the same as is basically saying the exact same thing as equals 3 multiplied. And here's where it gets weird. Multiplied by, you might want to say 3 multiplied by 1 less than twice the number. That's why this is weird. It's actually saying 3 multiplied by this entire phrasing back here. Okay, so I'm going to put 3 multiplied by 1 less than twice the number. 1 less than, a lot of you guys try and do this symbol. The problem with that symbol right there is that means is less than. And we're not saying 1 is less than twice the number. We're saying 1 less than twice the number. So if I say that I have $2 less than my daughter, I'm subtracting $2 off of what she has, right? So this is a subtraction phrase, 1 less than twice the number. Where it gets weird is I don't take 1 and subtract twice the number. I'm actually doing 2x minus 1 in this situation. Again, if I think about that whole thing, I'm just going to come down here to the edge. If I have 2 less than Ruby, ooh, that just moved my camera, hang on. If I say I've got 2 less than Ruby, am I going to do $2 take away what Ruby has? Or am I going to start with what Ruby has and then subtract the $2 to get to what I have. Okay, that's one way you can kind of think about that. That's why it's backwards. From this point, honestly, once you have it set up, this is just like some of the videos that are on the notes. If you go back and watch the note videos, or look at the notes we took in class. So I'm not really going to work this out. The hard part of this is setting it up. So you need to go finish working that out by distributing and moving your variables together and all that. And then the last question I wanted to talk about was this: find two consecutive integers whose sum is 35. Because a lot of you probably don't know this word, consecutive. Consecutive means right after another. So for example, 5 and 6 are consecutive numbers. 11 and 12 are consecutive numbers, okay? So I know that you guys are good problem solvers. You can figure out two numbers that are right in order, that who have a sum, meaning addition, that add to 35. Algebraically, this is what it looks like. I've got two numbers, right, that need to add together to make 35. I don't know my two numbers, right? So I could say, oh, well, I've got x and I have y. X plus y equals 35. Problem is, two different variables. There's no way to solve that at this point. But there is a relationship between these two numbers. It's not just two random numbers. In fact, this second number is always exactly one more than the first one. Do you see that? So if we're talking consecutive, then the second number is exactly one more than the first one. 12 is 11 plus 1. 6 is 5 plus 1. Even if I went to consecutive numbers like 214, 215, I would say, oh, the second number is 214 plus 1. The previous number plus 1. So I'm going to say y is the previous number plus 1. Okay? Y'all see how we just did that? So I'm going to rewrite this whole problem, and I'm going to say, instead of two different letters, I'm going to say, okay, the first number plus the second number is always the previous number plus 1 equals 35. It's kind of a really advanced thing and thinking happening there, but it kind of makes sense if you think about it. Some mystery number and then a mystery number plus one more. That'll describe my two consecutive numbers no matter where they are. Now I can just solve through this. So I'm going to simplify first by combining like terms. If I do 1x plus 1x, I get 2x plus 1 equals 35. Then I can go from there and solve. Subtract 1, divide by 2, and all of that. If, for example, totally no reason I'm bringing this up, but if we're talking about consecutive even integers, then all of a sudden we're going to say, okay, well, I've got two numbers, x and y. Consecutive even integers, let's think what we're talking about here. We're saying like 2 and 4. 14 and 16, 296 and 298, right? So look at those and kind of see if you can see the pattern between how does this second number, how's it related to the first number every single time. Okay, think about that. Let's see who can figure it out, and I'll see you guys on Tuesday.